Hello, everyone. I'm Andre Gathigari from University of Denver, and today I'll be presenting PolicyPulse. This is a framework for precision semantic relation extraction for enhanced privacy policy comprehension. This work was co-authored with my PhD advisor, Dr. Sanchari Das from George Mason University, and Dr. Rinko Duri from University of Denver. So let's first start with what is a privacy policy. Privacy policy informs users about an organization's data collection and processing practice. It also tells users about third-party sharing or how long their data is going to be retained. Most importantly, policies inform users about control choices and mechanisms to access, edit, or even delete their data. But despite being such an important document, policies are rarely read because policies can be quite complicated. First of all, they are often excessively long, discouraging users. Language can be quite complex, requiring advanced reading skills, and use of ambiguous phrases often confuse users or lead to misinterpretation. Lastly, and most importantly, the text is unstructured, so finding relevant data can be quite challenging for users. So, in an effort to address these aspects, previous works have proposed alternate designs like short or multi-layer policies and even graphical formats, but they lack the challenge in lack of adaptation. So, researchers started exploring natural language processing for privacy policies, and this includes text classification to auto-label your policy text, information extraction pipelines, which can find relevant text according to a requirement like what are my user choice, and other application to summarize or to answer user queries, and even alignment by common topic. While looking at the current state, we observe that these researches are often isolated in aspect and have narrow coverage. For example, information extraction, while looks at collected data or the collector and even the purpose, overlooks what are the collection mechanisms, or if there are any conditional triggers associated with the practice. Often, information from a different practice category, like data retention, like what retention policy may apply to the collected data, is not accounted for. So for a more broader coverage for information extraction, categorization of information text as a processing step is necessary. With the current state of text classification for NLP, which is mostly focused at paragraph level, it lacks the granularity to extract artifacts related to this specific practice categories. And often, the methods are very tailored to a specific task, leading to lack of generality or generalization of the output, which can be widely used across various applications. So, to address that, we present a PolicyPulse. This is an information extraction pipeline that uses broader privacy-specific categorical components while preserving semantic relations within phrases and produce an output which can be widely used to support a wide range of applications. At a high level, PolicyPulse transforms a privacy policy into semantic units. These semantic units are then classified according to privacy policy practice categories, and depending on the semantic predicate and the categorical context, we mark phrases in these units with privacy-specific roles, which can then be used to support applications. So, let's start with semantic role labeling. Consider this example sentence. With semantic role labeling, we get 3 semantic frames, one for each of the verb predicate. The phrases in the sentences are also marked according to the predicate verb with a numbered arguments, which take different roles according to the verb. For example, if you look at the include semantic frame, the arg2 refers to a group, while arg1 refers to the things that are being included into that group. We want to take the semantic frame and give it the practice category. So the first 2 frame, we want to label it as first-party collection use practice. But at the same time, the second frame does not convey much information, so we want to skip it. With this idea in mind, we chose to focus on 5 practice categories: the first-party collection use, third-party sharing collection, data retention, user access edit delete, and user choice control, and added a second category of skip to remove noisy or irrelevant frames. Next step for us was to build a classifier. For this, we generated 14,000 semantic frames from OPP 115 corpus, and then manually annotated the semantic frames according to the aforementioned categories. We used an XLNet base model based on our previous research and tried different experiments. The first couple of experiments simply used the frame directly or added semantic or context in terms of the sentence tokens, but that poured poorly with F1 score just reaching 0.6. Next, we tackled the issue with low frequency of some of the categories with synthetic training data for them, and that improved the performance to 0.8. Lastly, we adopted a 2-layer architecture where the first classifier would identify whether to keep this semantic frame or discard it. And if it's kept, the second classifier will annotate it with the practice category. And that performed the best with precision near, or F1 score near 0.94, with individual categories having precision recall and F1 score with nearly 0.95. So continuing with the example, which is now semantic frames marked with categorical context, we want to label the phrases or the arguments from the frame with a privacy-specific role. And to achieve this, we analyzed the 14,000 semantic frames again and created a dictionary for 146 verbs, which were specific to practice categories, and identified 16 roles to mark the arguments into. So for example, the second semantic frame, the cookies would get marked into a collection mechanism where phrases like when you use our service will be marked as a trigger for that practice. Also, we accomplish a sentence level relations between this text. For example, IP address and GPS data in that first example are related to the location information through the roles. So now we have achieved a way to transform the privacy policy into units of privacy-specific categorical components with marked roles according to policy artifacts, which can now then support a wide range of application, which I will discuss next. Starting with analysis, we can now have a more granular insight into policy state. We applied PolicyPulse on 130,000 privacy policies from PP crawl corpus and basically plotted policies with missing policy roles. And if you look at the data retention part of it, while most data retention practice mentions the data being collected, they fail to mention the duration or location associated with this retention. Other application can be to auto-generate alternate policy designs. So on the left, we have a short notice generated from PolicyPulse output, where information such as what data is being collected or the third parties can be queried from FPCU and TPSC frames respectively with the policy role or the practice role. Also, since this is auto-generated, the link between the frame and the sentence is there. So if a user is interested, they can also expand that information. The preservation of relation between different roles also enable us to generate a nutrition label, for example, where the relation between personal information and marketing can be extracted from the frames. Also, since we have categorical context, we can distinguish between first-party and third-party practices. The last application that I will discuss today is question answering. So PolicyPulse can also be applied on a question. And with that, you get to know what the question is asking based on a category and a role. So if we look at the second example, the question gets marked as a data retention question, where the thing being queried is a time period. What we can do is have a set of semantic frames from PolicyPulse, which satisfy these two characteristics, and employ something like semantic similarity with word movers distance to find the most relevant semantic frame and present the answer to the user. So what we have discussed till now is that PolicyPulse provides granular analysis to facilitate broader information extraction and to support wide range of application. Looking ahead, we are looking into capturing relations across sentences, also use a classification-based role mapping instead of a dictionary, and incorporate more categories like practice specific to international specific audience. And we also want to have a more normalized form of representation of this extracted data and are looking into novel use cases for this granular information. Our data sets and models are available at the GitHub link. There are further more details on the paper. Please, if you're interested, give it a read. Thank you, and I will take some questions now.
All right, do we have any questions? I'll maybe get started with the first one. Could you elaborate a little bit on the dictionary? So I can imagine there's a reason why you want to move to a machine learning based approach as a future work, but what were the difficulties for putting together the dictionary and what are its current limitations at the moment?
So the issue with dictionary is that the verbs, so the dictionary is structured in such a way that you first query a verb based on a predicate, then you look at the category, and inside that you again get an numbered argument to your privacy-specific artifact roles. Issue is that since it's static, it's not, I won't consider it entirely robust against the wide range of language generally used in a privacy policy. Good thing with classification is that it's more robust, and with the dictionary, if the key does not exist, you do not have an output. But with classification, at least, we can scale more widely. So that will be the reason to move towards a classification-based approach for role mapping.
Okay, and do you expect any problem with the presence of legal jargon in the policy descriptions, or how does the dictionary handle that?
So the dictionary, since we're employing semantic role labeling to identify the key for the dictionary, and the labeling does not, it looks at the structure of how the language is written rather than the content. Okay. So the jargons will not affect the use of dictionary per se.
Okay.
But for classification-based approach, that might be an interesting thing to experiment with and see how it performs.
Mm-hmm. Thank you. Great. All right. Are there any other questions? Yes.
Thank you for your presentation. I was very interested when you showed the how it's unstructured and it has very complicated jargon, so people who might not have highly advanced reading skills might not be able to fully understand. Do you feel like that's done by design?
I think design can help, at least painting the snapshot of the information. As a user, I would imagine throwing the entire text at them is very discouraging, right? But if you provide a snapshot with a good alternate design and something clicks with the user like, I want to explore that more, then that link should be there. And that's why I think NLP can come in handy, which will preserve that link, right? With the granular, broader information, user can just expand, read more if interested. So I think it helps with building the context and expanding information gradually and aiding in the process rather than discouraging them with the entire text, I'll say. Did that answer your question?
Thank you.
Do we have other questions? Yes.
Thanks for your talk. I was wondering whether you have any idea about the legal implication of this. So when you actually basically shorten the privacy policy with your semantic tool, whether if someone makes a decision based on this shortened version, whether this is still legally binding then?
I won't consider it legally binding because this was not provided by whatever the PolicyPulse generates, right? This is our processing to aid the users, but it's not something that the organization provided, thus not binding it to a legal contract, I would say. So just to be treated as an analysis and accessibility tool, but not to be considered as a legal representation of the practice, that's it.
Okay, and I think this now concludes the questions. Please join me in thanking the speaker again.